see the physics, I can go to view assignment. When you see physics, I assigned the physics to 544 students. We were 544 in class, but only 110 submitted their work for marking, and they're already marked. You see this, and they're already marked. So if I click on the mark, I'll be possible to see those which are already marked. They are down here. They're down here. There is a twin Agatha with 73. Betty Ageno, you did the exams late, but you got 63. Prosi and Aimisibe, you got 27. There is Allen, you got 67. There is Eric Anderson, you got 90. There is Alvin Bashir, you got 87. So these are the marks up to the last point here. So the best so far in our paper, we have 2 with 96. There is Ronald Motesa with 96, and there is there's some other person with 96. We have 2 people with the 96. And as I told you, we are going to do, when you're going to do the paper, I told you the best is going to go away with a bottle of soda. Agaba, you got 97. Agaba is saying that he got 97. Let me check Agaba. Let's check Agaba. Okay, Agaba with 97. Okay, Agaba, can you raise up your hand, Agaba? Agaba, you raise up your hand. I want to unmute you and you talk to us. Agaba. Yep, I can see you. Yeah, Agaba, can you unmute? Okay, Agaba, good morning.
Good morning.
Good. You got 97?
Yes.
Good. That means that you're the best in this physics test. And I told you that the best person takes away a bottle of soda. Which type of soda do you like most?
Mirinda apple.
Mirinda apple. I'm going to give soda to 3 people. I will give to Motesa. I will give to Agaba. And there's some other person whom I'm looking for the number. I mean the marks. We are 3 people. So you will have your soda ready with me right away after this lesson, okay? Is that okay, Agaba?
Yes.
Yeah, make sure you maintain that performance. Okay. So Agaba, can you read for me your mobile money number?
0782
82
623
623
725.
725. This is Agaba who?
In the name of Star Rami.
Okay. Let me repeat for you the number 0782
Yes.
62
Yes.
37
Yeah.
25.
Yes.
Good. You have won yourself a Mirinda. You said the Mirinda what?
Yeah. Apple.
Mirinda apple. Good.
Yeah.
Please, it is not for airtime, it's not for data. Okay?
Mm.
It is for Mirinda apple.
Yes.
Okay.
Thank
Then
you.
can I see Kutesa? Kutesa, can you raise up your hand? Kutesa, can you raise up your hand? Kutesa. I don't see you, Kutesa. I wanted your mobile money number. Kutesa. I don't know whether he's around. Wherever you are, you have to contact me. Chirabo says that I passed everything. Zara says that he didn't mark all my answers. Okay, like when it came to marking, there were some other errors in the system, so I make the correction as well. So today we are basically going to make some corrections, okay, on the paper, especially where people failed. I'm going to display the questions. I'm going to display the questions, then we make the corrections together. We are starting with the question number 1. The question number 1, we are making correction for all numbers. So if you know you have failed any number, then this is the time to make the correction. Jacqueline says, teacher, you didn't mark all my answers, please. You will send it back possibly, but there was a problem with our system. Others would submit, others it would fail to save. So we are very sorry for that. For any irregularity, you know, we are using online stuff. For any irregularity, we apologize for it. Good. Can somebody define for us density? You can raise up your hand. I give you the chance to talk. Hello, Martha. Hello, Martha. Okay. Yes, Agaba.
Yes, sir.
Can you define for us density?
Density is mass per unit volume.
Mass per unit volume. Density is the mass per unit volume of a substance. That is very good. That's how we define density. Just somebody to remind us, what is the SI unit of density? I want to pick one person. Topista, are you there? Topista? Topista? Topista is not there. Let me see. Elizabeth, Ellie? Chirabo, Ellie.
Yes, please.
Can you discuss for us number 1?
The whole of number 1.
Yes.
Okay. Number 1, density is mass per unit volume of a substance.
Yes.
Then the SIU unit. Then part B, Roman 1, the question is the density of a metal is 8.9 grams per cubic centimeters. What does it mean? It means that 1 centimeter cubed of a turtle has a mass of 8.9 grams. Then Roman 2, what is the importance of this value? It helps us to determine if the object will float or if its density is lower than the one of the medium is in. That's the answer of one.
Okay, good. Wait, before you continue.
Yes.
You have defined for us density. You're saying density is mass per unit volume, no, sir?
Yes.
Can you give us some of the SI unit of density?
The SI unit of density is kilogram per meter cubed.
Or other units?
Grams per meter cubed.
Okay. I'm seeing Ronald Mutesa has come here now.
Excuse
He's
me,
calling herself
I have a
Topista.
question.
Yes.
The thing is that I've seen the marking. I passed everything, but you gave me 53.
Surely.
Yes.
Now what you're going to do, you will forward it back, okay?
Okay.
Yeah, you forward it back through that Google Classroom still, okay?
Yes, teacher.
Yeah. But did you answer all the questions?
Yes, I answered all the questions and you marked them, but you gave me 53.
Because some people submitted and some work were not seen, okay?
Okay.
So the work which is not seen, I could not mark.
But teacher, my homework was seen.
It's fine. You forward it back. You never know, you may get 100 and you also take a bottle of soda.
Yes, teacher.
Okay, please. So the SI unit of density is kilograms per meter cube or grams per centimeters what? Centimeters cube. Now here they're saying a rectangular piece, the density of a metal is 8.9 grams per centimeters cubed. What does it mean? You said it was what? What was your answer? So the density of a metal is 8.9 grams per centimeters cubed. What does this one mean? This statement means that 1 cubic centimeters of a metal weighs 8.9 grams. That's the meaning. 1 cubic centimeter of this metal weighs 8.9 grams. Then, or you can say, for every 9.8 grams of a metal, it occupies 1 cubic centimeter, a volume of 1 cubic centimeters. That would be the answer to that. Most of us passed it. Teacher, I got 2 marks, 156 and the other one 82. Which one is correct? There are some people who submitted 2 answer sheets. You find on top you have written, let's say, Akelo Barbara. Then on another page you have written Apio Evelyn. So what I do, I'll assume that you were 2 on the same phone. So what I did, I will mark from the first page up to where the other name comes in. I will count the marks I give to the first person. Then from the other one, I'll also mark and then I give to the second person. That's why probably Namsugubuga, you have 2 marks. So that is what it is there. Okay. Good. Then number 2, what is the importance of this value? The importance of density. Who can give us the importance of density? Yes, HP. Patrick. Patrick, what do you think are the importance of densities? Let me hear from Juma. Juma? Okay, Birunji? Hello, Birunji. Okay, let me hear from Melody. Melody? What do you think what are the importance of densities?
Density helps us to know the difference of substances if they are heavy or light.
Very good. Then another one. Density also helps us to determine. It helps us to determine whether the substance will sink in water or not.
Helps us to identify substances.
Okay, that is okay.
Density also helps us to identify substances.
Very good. Chirabo Elizabeth also says it will help us to determine if the substance will float if its density is lower than that of the medium is in. Very good, Elizabeth. We said that a substance is able to float on water if its density is less than that of water. And we said that a substance will sink in water if its density is greater than water. So those are the importance of densities. Good. Now, part C is a calculation of which I was very happy with this calculation. Most of us got it right. I was very happy with it. Let me open where we are going to calculate it from. So the number was saying that they're saying that a rectangular piece of glass has a density of 140, has a mass of 145.8 grams, and it measures 2 centimeters by 9 centimeters by 3 centimeters. Find its density and express your answer in kilograms per meters cubed. I was very happy. Very many people got it correct. Who can tell us what to do first? Patience. Patience, what do we do first?
First, find the volume.
Very good. Volume is going to be
2 centimeters times 9 centimeters times 3 centimeters.
very good. 2 centimeters times 9 centimeters times the other centimeters. That was good. So when you multiply that, what do you get?
54 centimeters.
54 centimeters cubed. When you get 2 centimeters by 9 centimeters times this, you get 54 centimeters cubed. That is the volume. Then from there, we are asked, the mass is already here, no sir? This is the mass. So if the mass is already given to us, we have the volume, then we get the density from density equals to mass divided by volume. Is that okay? Somebody is not able to find the results using Google Classroom. Happy Mary, you go to Google Classroom, you go to your class, you go to assignment. Good. So from there, you get your mass is 145.8 and the volume is 54. When you divide it, what do you get when you divide?
When you add this, when you
Okay. So remember our volume is already, was it 2
you do like this
times 9, then times what? Was it times 3? So what did we get? 54 centimeters cubed. So this is our volume. Hello, you meet yourself. Meet yourself. There is noise in your background. So we have the mass already. Our mass was already 145.8. So to get the density, we say density is mass divided by what? Divided by volume. So our mass is 145.8 divided by 54. So what do we get? You can raise up your hand and you take Melody, what do you get when you divide that?
You get 2.7 grams cubic centimeters.
2.7.
Yes.
2.7 grams per centimeters what? Centimeters cubed. But remember, they had said that our answer should be in what? In kilograms per meters cubed. So we go and we convert. We already know that 1 gram per centimeters cubed is equal to 1,000 kilograms per meters cubed. Then what about 2.7 grams per centimeters cubed? It will be equal to 1,000 times 2.7. What do you get when you multiply this? Yes. Yes, Rita. Hello, Rita. What do you get?
2,700.
It is 2,000.
700.
Very good. 700 kilograms per meters what? Per meters cubed. So this is what I expected from you as your answer. Most of you did it, but somebody failed to convert from centimeters cubed to kilograms per meters cubed. But most of us did that number and we are getting it right. Was very happy. Good. Let us go to the next number. The next number says a student carried out an experiment as follows. He placed water in a basin and carefully and gently placed a piece of wood on the water surface. He observed that the piece of wood remained on water surface. He repeated the same experiment, but this time he used a small stone instead of wood. He observed that the stone sinks in water. Can you explain the observations? Okay, who is willing to take us through that explanation? Katonomase is asking, where do we click to raise up the hand? You go to on top there, you must be having an option for reactions. So you go and press there, reactions. You raise up your hand. So who can take us through? Oh, Blicky. Blicky, how are you? Hello, Blicky. Blicky? Okay, let me hear from Sadiq. Sadiq. Okay, let me hear from Dr. Nabatukuvu Elizabeth.
Good morning, teacher.
Good morning, how are you?
Good morning, teacher.
Good morning, how are you? How are you, doctor? Oh, I wanted you to answer for us this question, but you've gone before time. Can you answer for us this question? Somebody should raise up their hand and answer for us this question. Okay, I see some hands up. Yes, I call Juma. Juma? Yes, Juma.
It is because the density of wood is less than that of water. It is because the density of wood is less than that of water.
Okay, Juma, your network is okay. Let me hear from Loisa. Loisa?
The observation, the first part of
Yes.
the first part of the experiment explains
Yes.
that a piece of wood is less dense than water, and the second part explains that a small stone is denser than water.
Very, very, very good. Very, very, very good, okay? That was good. On the chart, somebody is saying that Chirabo Elizabeth is saying, when a piece of wood in a basin of water remains on top or float on water, this is because the piece of wood is less dense than water. Very good. While when the stone is put in the basin of water, it sinks. This is because the stone is more dense than water. Good, Elizabeth. Good, 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 Elizabeth. That was good. So we said for something to float on water, it must be less dense than water. And for it to sink in water, it must be more dense than water. So here we see wood floating on surface of water because wood is less dense than water. We see stone sinking in water. That implies that stone is more dense than water. Good, good, good. I have serious engineers in senior 1 class. Serious ones. I think I should be talking to your dad one by one so that at least you enjoy physics. Then after enjoying, you become great engineers. Yes, I know some of you can do it. Oh, this number was failed most. Number 2 was failed most. Out of the 3 numbers, the worst done one was number 2. And yet it looked to be very simple. Question A says, you are provided with the following: liquid X, solid Y. Please, it is liquid and solid. Measuring cylinder, water, weighing scale, a beaker. Question number 1. Describe how you can determine the density of X and Y. What was our X? Our X was a liquid. In other words, the question wants us to describe how we can determine the density of a liquid. Is that okay? Okay, now you raise up your hand and you give me the answer. Rita Nambobiro. Rita Nambobiro, when I pick you and you delay, I give you a chance to another person. Rita Nambobiro. Okay, Jotham. Jotham.
I'm hearing, teacher.
Yeah. Jotham, can you take us through how we can determine the density of liquid X?
We can determine the volume, we can determine the density of liquid X by first measuring the volume of liquid X.
Very good. Using what?
Using a measuring cylinder.
Very good.
Then the measurements will be recorded as the volume.
Good.
Then get the empty beaker and measure its mass by using a weighing
Very
scale.
good. Very good.
Then those measurements will be recorded as M1.
Very
because
good.
that will be our first mass.
Okay.
Then put liquid X measured in the beaker and measure its mass using the weighing scale. But this time we put the liquid X in the beaker.
Very good.
Then the measurements will be recorded as M2.
Very good.
Then our density will be M2 minus M1 out of the volume.
Very, very, very good. Thank you so much. Thank you, thank you, thank you. That was good. I cannot add anything now there. Somebody saying on the chat, the teacher, who is that? Shida-shan. Teacher, I request that you pardon me on the answer for question 1D. Question 1D, let me check. Question 1D, okay. A student carried out an experiment as follows. He placed water in a basin and carefully and gently placed a piece of wood on water surface. He observed that the piece of wood remained on surface of water. In other words, the piece of wood never sank down. He repeated the same experiment, but this time around using a small stone. And what was observed was that the stone sank in water. Can you explain this observation? Yes, the piece of wood remaining on top of water, it means that the density of water is greater than the density of the wood. And so a piece of wood can never enter in water as long as the density of water is greater than its density. So we make a conclusion by saying that the density of wood is less than that of water. The stone was able to sink in water simply because the density of stone is greater than that of water. And so it can never float on the surface. Let me hope I'm okay, Shida-shan. Please let me know, Shida-shan. Dr. Nabatuku says, teacher, can I get correction from Google Classroom? It's okay. I'm going to type the correction, the marking guide. Unfortunately, I have not yet typed it. I'm going to type it. It is handwritten right now, but can even come scan direct to Google Classroom. Teacher, I have an answer for number 2. That is, teacher, I have an answer for number 2. Teacher, I have an answer for number 2. That is, Chirabo Elizabeth, you have sent for measuring liquid X using a measuring cylinder, while using a weighing scale, then transfer it in a beaker using this and this. Good. Teacher, you mean you can't hear, sir? Teacher, I didn't get number 2, I1. Do we submit correction? No, don't submit the correction. Okay, let us see how do we determine now the density of solid Y? You can raise up your hand. How to determine the density of solid Y? We have seen how to determine the density of a liquid. To determine the density of the liquid, you use a measuring cylinder to measure the volume of the liquid. Then from there, you first weigh a beaker. After weighing the beaker, you record its mass M1. After doing that, you pour the liquid in the measuring cylinder, in the beaker, and you record the mass of beaker plus its content as M2. Then you get the mass of the liquid from M2 minus M1. Then the density will be the mass of the liquid divided by the volume, as we saw. Good. Teacher, some of us are asking for the timetable. How can we get it? We shall send for you the timetable. Who can explain for us? Number 2, how to determine the density of solid Y. Raise up your hand. Density of solid Y. Yes, Jacqueline Nakawaj. Jacqueline Nakawaj. Your network. Let me pick another person.
Teacher,
Yes, please.
I can determine the density through pouring liquid X into the beaker.
We are determining the density. No, we are determining the density of the solid now.
The solid.
Yes, solid Y.
I hang the solid Y onto the weighing scale.
Yes.
Then I first find the mass.
Yes.
I get the measuring cylinder.
Yes.
Containing water in it.
Yes.
Then I place solid Y in the measuring cylinder.
Mm-hmm.
After I see the second volume, then I say first volume minus second volume, second volume minus first volume. Then I find the volume of solid.
After getting the volume, good, thank you so much. I think we have gone off. Let me hear from Annabella also. Annabella, how do you determine the density of that solid? Annabella? Annabella? Okay, let me hear from Shirabo Elizabeth.
Excuse me, teacher.
Yes, Ellie.
Like for me, my answer, I like that one of determining the density of X and Y. I all did it at the same time. Like I mixed it with only one answer and I formed only one answer. So should I tell it to you?
You're supposed to separate because these are two different substances. You're supposed to determine the volume of the other one first, and then the volume of Y separate also as well. Okay, good. Let me hear from Melody.
Teacher?
Yes, Melody.
To get the mass, we put the solid on a weighing scale and record the measurements.
Very good.
To get the volume, we put the solid gently into the measuring cylinder with water, and the water will rise. So we subtract the original water level before putting the solid and the water level after putting the solid.
Very good.
The answer is the volume of solid Y.
Very good.
Yeah.
Then, remember you determine the density. You have determined the mass already, you have determined the volume. What next?
Then you find the density.
From where? Melody? Melody? You find the density from? Okay, from density equals to mass over volume. Is that okay?
Yes.
Okay. Good. Let's see. That is that. Then there's this. It was a calculation. That's how we can determine that. Now, part 2 says, if density of X is more than that of Y, determine what would happen if Y was placed on the surface of X. Please, density of X, remember our X, in this case, it is the liquid. Density of X, which is the liquid, is greater than density of Y, which is the solid. So the density of the liquid is greater than the density of the solid. What would happen if the solid was placed on the surface of the liquid? You can give us the answer. You can give us the answer. Yes, yes. But there are people who are down here and you're not raising up your hand for sure. No, 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 no. I will go and pick from down. There are those who are not raising up their hand. I'll come and pick you from down here. Wangolola Benjamin. Wangolola Benjamin. 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 Peter Wafula. Peter. Peter Wafula, can you unmute and talk? Okay. So who can tell us what would happen? Let me hear from Loisa. Loisa.
The
Yes.
object Y will float.
Object Y will float on X. You deserve a very good.
Excuse
Can
me,
you give us
teacher.
the reason?
Float.
Okay, good. Let me hear from another person. He's saying that it will float. Jotham. Jotham.
Yes, sir.
What will happen?
For me, what I think, it will float on water because surface X, it is water. So when solid Y is less than X, it could not sink because it is less than X. So it will float on water.
Very good, very good, very good. But before you go away, Jotham, Jotham, do you hear me? The liquid X is not water, it is a liquid, but its density is greater than the density of the what? The density of the other substance. So it will not what? It will not sink in that very liquid. Thank you so much for the wonderful submission. Okay, now we are going to see the other calculation bit. There's this part which says this and this. I want us to write that one down. Let me. So the last number was here.
Possible. Bossy.
It was 0.008 centimeters cube of fresh water of density this is mixed with this of water. I think we have it here.
Close.
It was this. So the question was this one. I think you can see on my screen.
Yes, teacher.
Can you see on my screen?
Yes, teacher.
Good. It was 0.0018 meters cubed of fresh water of density. This one was mixed with 0.00022 meters cubed of seawater of density. This one. Then they wanted us to find the density of the what? Of the mixture. Is that okay?
Yes, teacher.
So we have fresh water. We have fresh water.
Excuse me, teacher, can I give the answer?
Yes.
Okay. Okay, I first found the mass since they had given us the density and the volume.
Yeah, density was already given. Tell me.
It was 1,000 kilograms per meters cubed.
Yeah, density was 1,000.
Kilograms meters cubed.
Yes.
Then the volume was 0.0018 meters cubed.
Very good.
Then I had to first find mass.
Mass.
Which is equal to density times volume.
Density times volume.
Which is equal to 1,000 times 0.0018.
1,000 times
0.0018.
Which gives you what?
Which gives us 1.8 kilograms. Since the SI unit of mass is kilograms, so the meters will be.
Very good. So this is mass of fresh water. You can call it M1. Very good.
Then we find the mass 2 of the seawater.
Seawater now. We are talking about seawater now.
Yes.
Yes.
You said mass 2 is equal to density times volume.
Density times volume, that is mass 2.
Which is equal to 1,025.
1,025
times 0.0022 kilograms per meter cubed.
Times 0.0022. 0.0022. 0022.
Then the answer is 2.255 kilograms.
2.255 kilograms.
Then afterwards,
yes,
you find the density of the mixture.
Density of the mixture
is equal to mass 1
equals to mass 1
plus
plus mass 2
divided by volume 1
divided by volume 1
plus volume 2.
plus volume 2. Very good.
Then which is equal to
Yes.
1.8
1.8
plus 2.255
plus 2.255.
then divide by
0.0018.
0.0018 plus 0.0022.
plus 0.0022.
Then the answer is
The answer is
1013.7 1013.75 kilograms per meters cubed.
75 kilograms
per meters cubed.
cubed. Is this one Elizabeth?
Yes, teacher.
Oh, Elizabeth.
Yes.
Thank you, Munonga.
You're welcome, teacher.
Thank you so much. This is too good. Oh, thank you, thank you. So up for sure for this. I think I don't have any other thing to add on this. She has explained it all, unless there's somebody with a question. If you have a question, you can raise up your hand. If you have a question, you can raise up your hand. Our time is up. Our time is up. Yes, Melody? Melody? If you have any question, you raise up your hand. Melody?
I don't have a question. I forgot to lower my hand.
Okay. Mercy? Yes, Mercy. Okay. Mercy? Okay, fine, thank you. For any question, you can contact me. I can give you my number. It is 070-375-0387. Our time is up. We are going to end the meeting. We shall discuss other things in the next lesson. So 070-375-0387.
Excuse me, teacher.
Okay, please. Yes.
So now, like, I should again take the pic of my work. Then I again send it on the Google Classroom.
You can just resend that one.
Okay.
Yeah. Okay, fine. Thank you so much for being good students. I love senior one for sure. You are too good, too good. I don't know what I can compare you with. See you in the next lesson. Goodbye for now.
Bye, teacher.
Bye. Bye.
Question.
Yes.
Do we send the correction?
No, you don't send the correction. Don't. The correction is for our own benefit, okay?
Yes.
Okay, please.
Teacher.
Thank you, teacher.
Yes.
I've been putting up my hand the whole lesson, but you aren't choosing me.
Oh, sorry. Who is this person?
It's Galaxy. It's Cantonomasi.
Katonomasi, I remember picking you, but you did not talk for sure,
No,
my
it
sister.
was in the text. I texted that where should I clicked raise my hand. I clicked, but you aren't choosing.
Oh, sorry, Mercy. I'm very sorry for that, Bambi.
It's okay.
I'm sorry for that, Mercy, okay?
Yes.
I promise in the next lesson, okay?
Okay.
I'll even make you the class counselor. Okay, I'm very sorry for that, Mercy, okay?
It's okay.
Kale. Fine, goodbye for now.